We got done? Oh, I guess y'all didn't know what to do with it, right? Who's done? I was walking out. Yeah, I'm sitting up there. Something around. You drawing?
didn't send you this?
Are you done? So, Julia, Adele, Stephen, are you guys done? Which one was the tricky one? The last one was real, like just like one from the homework, wasn't it? We did it in class. Did we do that in class?
But it was the opposite way. The one that we had to change was first one that says exit.
You had one of the, where we were scared. You were texting me about this morning.
I know. I think I did.
Okay, so yesterday, we were trying to figure out, I threw this up there and said, we don't know how to do this, right? You say, oh, there's this new formula that we're going to use to learn. It's the backwards product rule. Okay? And I think I wrote it down for you guys. I said, oh, this formula that we're going to use is this. Did I write that formula down? Yeah. You probably didn't. I mean, it's okay if you didn't, and you don't even necessarily have to write it down right now. We're gonna sort of show you where that formula comes from, and then show you how to use it. Using it is probably more important to you than knowing necessarily where it comes from. But I do want you to at least see how it came out of the product rule. I'm not going to make you ever do this. In fact, I have to write it out. I can't just do it off the top of my head. I have to sort of write it out. So if I start back like a long time ago and I say, if we have a product of two functions, like this, right? If I ask you to take the derivative of that, you would say, oh, that's the derivative of the first times the second plus the derivative of the second. Oops. Oh, that's ugly. Plus the derivative of the second times the first. Right? Isn't that the product rule? Yes. I think it's easier to talk like this. Okay, so yeah, that's the product rule. All right. So what happens if I undo that? How would you undo that? Take the antiderivative of both sides, right? So what happens if I antiderivatize both sides of that with respect to x? Well, the antiderivative of the derivative is just that, right? The antiderivative here is going to be f prime of x, g of x, with respect to x, plus the antiderivative of g prime. Whoa, 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 whoa. You guys, hey. There's a typo up there. You just let me just write that. I said, oh, yeah, you get no 1 second. What's wrong, Megan?
F prime of x cannot be
Derivatized?
Yeah.
Okay. So now you can see if I solve this right here for fg prime, I'm going to get that. You see that? If I solve this right here for the integral of fg prime, so that, which is this guy right here, and I can rewrite that as f of x, g prime of x. So it'll be f of x, g of x, minus. Oh no, I'm going to run out of room. So that's where this little rule comes from, or this equation comes from. Yeah, so what? How do you use this?
Wait, why do you have to move the side that comes on?
What's that?
Why do you have to like move it over to the other side?
Because I gave you this and I said, where does this come from? Well, this equation right here is what you get if you solve this right here for that. If you move that other piece to the other side. All right, so what? How does this work? How do we use this? Okay? That's what we're going to figure out. Oh, that's deplorable. Look at that mess on there. Do you see that? You guys see all that residue? So, perfect. I'm going to rewrite this up here just so we have some room. So we're going to write the integral of f of x times g prime of x dx equals f of x times g of x minus the integral of g of x. Okay? All right, here we go. So what we're going to do is when we have an antiderivative of a product where we can't do a substitution, because we already established why we can't do a substitution yesterday, right? We're going to treat one of those as a derivative and one of those as a function, and then we're going to apply this formula. We're going to set it up and say, okay, I'm going to pretend that one of these functions here is g prime, and the other one is f. We have to figure out which one's going to be which. And then we're going to apply this formula. Okay? So I'll just tell you for this one, f's going to be x. And g prime is going to equal sine of x. Okay? And technically, g prime is going to be sine of x dx, because it's going to be that whole piece. Okay? As soon as you do that, if you notice, how many parts are in this formula? How many different functions are involved in this formula? 4. There's f, f prime, g, and g prime. I've only identified f and g prime. So what do I have to do? Find the other two. Okay? So I'm going to find the other two. Well, if f is x, what's f prime? 1, let's say 1 dx. Okay? And if g prime is sine x dx, what's g? We got to work backwards. We got to find the function whose derivative is sine. It's negative cosine. Okay? So now I'm going to apply that formula. This integral right here is going to equal f times g. So that's this times this. Minus the integral of what? G f prime. Okay? And honestly, if you want to put the dx here, you can. If not, it's not a big deal. So g f prime is going to be negative cosine of x times 1 dx. And now what do we do? We have one more step. What's our next step? Gonna do this. Just gotta compute it. Now hopefully it's one that you can do. So first I'm gonna distribute that negative and put plus. So what's the antiderivative of cosine of x? Sine of x. And then plus c, there's our answer. Right? So in it, this is called integration by parts. There are 4 parts that you have to identify. F, G, F prime, and G prime. Yeah.
How do you know that like f of x is x?
Right. So that's the $1 million question. I mean, I'm surprised you asked it this early, but it's great. Like, how do you know which one to set up which? Is it just because that one came first? No. You have to set them up based off of what you have to do to them. So what I decided to be F, okay, what I decided to be F, you have to think, well, what am I going to do to that? What did I have to do to the F? If this guy here I decided was F, what did I have to do to it in the first step? I had to find his derivative. The thing that I decided to be G prime, what did I have to do to it? I had to antidifferentiate it. So your choice for F is going to be something that you can take the derivative of easily, and your choice for G prime is going to be something that you can take the antiderivative of easily. Another rule of thumb is your choice for F typically is something that gets simpler when you differentiate it. Like x squared becomes 2x. Does that make sense? Now that's a rule of thumb. It's not always the case. See, when you flip that little switch on that coffee pot off, you're gonna have burning coffee or something. Yeah.
So does it matter? Like, can you have?
Yes. It wouldn't work the other way. Okay. In fact, just set it up and try it. You'll see what happens is if you flip these around, this is going to get more complex. The problem is going to build up in complexity on this side, and that's not helpful. Okay. Now I will tell you, I used F and G here to introduce this to you, but a lot of books, including ours, instead of using F and G, they use U and V. And so they do it like this. They'll say the integral of U dV equals UV minus the integral of V du. Now that looks scary when you first see it, but if you just think of U is f of x and V is g of x, it makes sense. Because like, think about this. If V is g of x, what's dV? G prime. Okay? And if U is f of x, what's du? F prime. Okay? And maybe I'll do one like our next example we'll do using U and V, just so you see how it works. I mean, it's interchangeable. Okay, let's try another one. You ready? Okay, so I'll use that U and V thing this time, just so you can see another look at it. So I always start off like this. So you're going to let U, or F, be something that gets simpler when you take the derivative. And you're going to let dV be something that is easy to anti-differentiate. So what do we think? U is x. Becca, what do you think dv should be? E to the x, okay? Technically speaking here, friends, there should be a dx here. But if you don't write it, I'm not going to like flip out, okay? But technically speaking, there should be. All right, now, what's du? 1 dx. Technically speaking, there will be a dx there. If you forget to write it, we're not going to freak out necessarily. It's just being good. It's like using good grammar in English class. All right, what's v? E to the x again. Okay, now someone might ask, why do I not have a plus c here? Anybody thinking that? Why is there not a plus c there? You found an antiderivative. Why is there not a plus c there? You could stick one there. Okay, you could stick one there, but then you're going to end up with 2 c's at the end, which just would combine the one big c. So there's no need for it. Okay. All right, so you ready to do the formula? What's our formula? We're going to use it this way. It'll be u times v minus the integral of what? ddu. And what's the antiderivative of e to the x dx? E to the x again. So this is x, e to the x minus e to the x. Plus choice. Questions so far? Which do you like better, the f or the u? You like the f? Is that just because that's how I showed it to you first?
Because that's the way that the formula.
It's probably a little shorter just using u and du. Okay, let's try this one. What's going on here? I like all those black streaks. Does anybody have any initial thoughts when you see this? Yeah, there's not 2 things there. How are you going to do this? There's not 2 things. Okay. Well, there are 2 things there. What do you mean do I have to do one? Like with 1 time. Like this, you mean? Yeah. Like stick a 1 in there? Yeah, exactly right. Okay. Now I only have one option here for f or u. There's only one option. Why? Well, I can. I'd get 0. I don't want that. And I also, if I make this g prime, natural log g prime, I have to anti-differentiate it. Well, that's the problem. I don't know the antiderivative of natural log, right? So f of x is going to be natural log of x. And g prime is going to be 1 dx. Or let's just put 1 there. Which you guys don't like right here. Natural logs make great choices for f. In almost any problem involving a natural log, that's going to be your f. Or your u. Notation. Okay, so we got 2 out of 4 parts. We got to find the other 2. What's f prime? 1 over x, what's g? X. Right? So here we go. It's f times g minus the integral of g f prime. What happens inside here? This becomes just what? The integral of 1 dx, which is x plus choice. Nice. Oh. What time do we get out of here? Yeah.
Didn't you show us that? Not like that.
Oh yeah, you
But
remember.
you were like, if you ever find that, just make it equal to that.
Yeah, if Elliott's remembering when I gave you, when we were learning the product rule for derivatives, I gave you this as a problem. And I said, oh, this is a function whose derivative is natural log. She remembered. So this is what you need to do. You need to start working on those problems that I bailed on yesterday. You're going to struggle. I mean, you're going to struggle. But the struggling is okay right now. Okay? Let's start working on it. Just see if you can set up what's F, what's G prime. It's on Google Classroom, yeah.
Okay. So when Julia started mentioning that they and dropped our grades, and I said, you never would. But they actually look cool. I would have like highlights. Yeah, it's never read in a story.
See you guys. Oh crap, we gotta sanitize. Stop. Sanitize. Sanitize the air. What's going on, Noah? How are you? Tired. Where do you work? Outback. Outback? Where is there an Outback? Big mall. Outback. Australia. I didn't know Outback was still even. Where is it? By the Dayton Mall. There's that Sears Automotive building used to be. Oh, yeah, that's right. It's a huge Outback. Yeah. Well, like 1/4 of it is separated and it's like a seafood restaurant. Really, you don't have that much food? Yeah. I mean, I don't know, mine was maybe more hers, so. She's like, you never told me I had to wear that. Look at you guys all sanitizing. Oh boy. I said, oh boy. Short. 23. Wait, is that thing wrong? I was just talking about it and I was like, oh. I feel like I keep this for the last 4 years. Yeah, no. He's clean up his stuff. What do you think is he's going to do any better?
Does anybody have a spare Chromebook charger?
Yeah.
Guess you're gonna have to ask me.
That was like Wednesday.
Dude. Yes. No, be careful. There is a hedge fund that borrowed GameStop shares.
And they,
So then they-
I know the fact they were gonna go.
Yeah. Yeah. So a bunch of people bought all the shares so that the price would increase, and now the people that own the hedge fund have to buy the shares back and give GameStop interest. So, which is a lot of money, which means the people that they're gonna have to buy sell the shares from are getting a lot of money, and the rich people are losing a lot of money, and they're not happy about it, so they're just saying, no, you can't buy shares.
Absolutely.
I got a different one, they gave me a different one. What was it? No. It was a green can. Yeah. I want to eat. Yeah, I
You ready to record? Yeah, well, Amy said was about work. Okay. Yeah, I was gonna do homework.
No, this is my first time.
It's gonna be bad. I'm not gonna say it's going down to like.
Huh? What's up? Do I have to sign on it? You do. You have to sign an oath too.
You know? Spanish
Oh, I didn't talk to Miss Will. You already dropped it from date. Okay, so, can I take this to Miss Will? Sure. All right. Dropping like flies. Kevin got third in the G-Walk in diving.
They got first.
All right, so, you know what?
He said about first.
So you? I was wondering if you belly flop. That causes you to get very hot.
Have you ever done
It's like in practice, not in. So you wouldn't try something in a knee, but. Correct. They're what? Dope? Well, I kind of love them. I didn't design them.
I know my cat.
I don't know. The only thing I think is would have been different with the shirts is if we would have made a more of a pun on the keeping the distance. Because really, this swimmer here should be like out in front with other people behind.
Should have done Cobra Kai shirt.
Cobra Kai, I love Cobra Kai.
Yeah, that would have been way better.
All right, so you got some time here, like 15, 20 minutes. Are you going today?
I'm ready, but you should send it.
You peacing out?
We study also.
Oh, you can't really study.
Like, we do, but we're not from the top yet, so. I don't know.
What you were saying here. I mean, they don't want you out wandering the halls and smoking in the bathroom.
Yeah.
What is that?
Oh, Vaseline. I get bloody noses and Vaseline.
Is it cigarette?
I caught my nose cauterized twice. So what?
When I was very, very younger.
It was like one day I was in class and I got a bloody nose. I went to the nurse for it, and then I got it stopped and I came back and it started again. And so I just missed the entire class because of it.
Done, dog.
No. No, I wouldn't say. Sometimes it's not. You can listen, you have to listen to him at home until it's different. Yeah, he's listening. I know, he places,
So funny.
he places a gospel thing for Calc2 Jan.
Oh,
I think it's like 7 grade or 16. But I read. Well, he went there. he goes to the basement, but he just sits in. And this is also, this is really like self-care. Victory has said, yeah. I don't know. I think maybe simple or something. I got a ticket from him before.
Okay, so we gotta be finishing here soon, like in the next minute and a half. Finishing. Young Billy, young William. Gavin, are you done?
I got one. I got one. I got one. At least one. One, natural water.
Yeah, I mean, we'll figure it out. I mean, you done? Number three, that maybe that we did. Maybe. Did you move?
Yeah, I was over there because I thought we need our graphic calculator and my laptop was there. So I was gonna get that one, but we didn't get it.
No bueno. Need that also. This one.
I was used to play soccer and then
You got sucked into it.
my sister wanted me to.
Are you still playing club soccer? It's like all those kids that just came out and swam this year. They're senior year.
Yeah, you could coach track.
I was concern with what you were hyping up trying to go for.
Hey, I'm hype up all the sports. I mean, try to get.
You coach tennis.
I used to coach tennis.
What?
Tennis seems like a fun sport.
You
No,
would
yeah,
have?
what's it?
No, but I might.
I coached tennis back when Rachel was a baby.
Once it gets warm again, it's Florence, sure. What is that?
Quarantine.
Quarantine? Oh.
That's hilarious.
Your E was like older.
All right, well, let's talk through this, my friends. Integration by parts. Oh, Samuel, Lily, have you been done this whole time?
No, I can't figure out one of them.
Oh, is it annoying you?
I kind of figured it out, I have no idea.
So yesterday we start off with this. We didn't start off. We ended yesterday with this problem, right? And we discussed why it's not doable with a U substitution. Yeah. I felt pretty confident that we all understood why it's not doable with the U substitution. So now we're going to learn how we go about doing this. Okay, and integration by parts is essentially undoing the product rule for derivatives. Okay, but it's not quite so straightforward. There's a formula involved for integration by parts, and once you master the formula, it's pretty easy to do. It's just sometimes tedious. So I'm going to show you the formula. I'm going to show you where the formula comes from, which I'm not so much concerned that you know how to show someone where the formula comes from, and then we're going to use the formula. Okay? Show you how to use it. That's what you really want to know how to do. All right? So, if y'all remember the product rule, so if I have two functions, right? And I say, hey, Gavin, take the derivative of those two functions, right? You know how to do that. Bill, you know how to do that, right? Yeah. It's like, oh, it's the derivative of the first times the second plus the derivative of the second times the first, right? That's the product rule, okay? Now I'm going to show you, before we dive further into this, I'm going to show you the integration by parts formula. I'm going to over here. Don't write this down just yet, okay? But I'm going to show it to you so you can see it unfolding as we go through this. Here it is. Okay, that's the formula for integration by parts. All right, so we're going to show you where that comes from. All right, so remember the product rule over here? Now again, don't write this down just yet. We'll get there. Remember the product rule over here? There it is. That's how you take the derivative of product two functions, right? Okay, well, just for funsies, I'm going to anti-differentiate both sides of this. Because that's what we want to do, undo the product rule, right? So what's the antiderivative of the derivative of f times g? It's f times g, right? And so here, if I do this each as individual terms, by the way, I'm anti-differentiating with respect to x, so I'm going to put a dx on this one. I'm going to put a dx on that one. Do you see what I wrote up there in the top right hidden in what I have written down here? Do you see it? It's not quite there. We have to move some things around. But if I move this over here, like that, and I rearrange it to GF prime, which is multiplication's commutative, so I'm allowed to do that. And then I rewrite this guy right here in a different order. You see that? It's just flipped. But that's that formula. Okay, now you might be saying, like, that's the super, like, that what? I mean, how am I supposed to use that? That looks like a bunch of gibberish. Okay? And it does look like a bunch of gibberish, I'm not going to lie. Incidentally, I'm going to show you this right now, but just another form of this formula before we actually use it. And this is how our textbook uses it, or shows it. Instead of using F and G, they say U is F of X and B is G of X. So then they write it like this. U, G prime, they would call dV. And then they would say UV minus, so that's F times G. And then they would say G F prime. And F prime they would call du. Okay? So these two formulas are essentially saying the same thing. But again, right now that just looks like a bunch of gibberish, right? I don't know, how are you supposed to use that? How are we supposed to put that in practice? Okay? So I want you to go back to this problem. The problem that started this whole mess. And then I'm going to say x and sine of x. Okay? I'll get you, hold on one second. So here's how we're going to do this. We're going to look at this integral, and we're going to look at it as if it's the left side of that formula. And we're going to say, hey, we're going to pretend one of these things is a derivative and one of them is a function. Okay? I'm going to say one of those is f, and one of those is going to be g prime. Follow me? So I'm going to tell you, let's let f of x equal x, and g prime of x equals sine of x. Okay? Now, Samuel, what was your question?
I got does it matter which one ask what one is?
Yes, it will matter. Yeah, and I'll show you why in a minute. Okay, I thought you were going to ask. Well, I'll wait. Someone's going to ask you. So if you look at that formula, how many different parts are there? How many different functions are involved? Look at both sides of the formula. How many different functions do you see? 4. You see f, f prime, g, and g prime, right? So we just set up from the problem f and g prime. So what do we have to do? Figure out the other two. Okay? So tell me what f prime is. You went the wrong way. Okay? It's easy to do. So, guys, I'll be honest, when you're doing integration by parts, you got to make sure you know if you're differentiating or anti-differentiating. Okay? And if g prime is sine, what's g? All kinds of arguing. Is it negative cosine or positive cosine? Negative. Negative cosine. Okay? So now I've got the 4 parts. Now all I do is just use the formula. I'm going to say the integral of x sine of x is equal to, what does the formula say to do? F times g. So maybe I can do that. Take the negative up front. Minus the integral of what? G F prime, right? G F prime. So negative cosine of x times 1 dx. And now what do? Are we done? We just do this guy right here. So I'm going to minus those and make a plus. I don't need to write 1. What's the antiderivative of cosine of x? The negative or regular? The antiderivative of cosine.
Regular.
Regular sign. Okay? And then what do I need? Chips. So 2 questions that immediately come to mind. And I bet you the 2 questions that I'm going to point out, or one of them is the question Samuel, I just said Stephen. Samuel just said, or was just about to ask. 2 questions. The first question is, how do you know which one to make F and which one to make G from? Is it just because which one came first? No. Okay? There's some strategy involved. Right now, let's say our strategy is this. We're going to choose for F something that we can differentiate easily. Because that's the first thing you got to do, right? As soon as you figure out what F is, you got to find its derivative. And we're going to choose for G prime something that you can, what do you have to do to him? Anti-differentiate easily. Okay? So that's where we'll start. So like things that make good F's are like powers of X, right? Things that make good G primes, trig, exponentials. Those are easy to anti-differentiate, right? The next question that comes up immediately is what about the chips? Because shouldn't there be a bag of chips right here? When I went from here to here, shouldn't I have had a bag of chips there? Yes, I should have. But when we go through all this, that bag of chips will just carry in, and then we could have 2 bags of chips down here that will just combine and make one big bag. Family size. Okay? So you don't have to worry about the chips midway. Okay? And I agree, there is no such thing as family size chips. Because they're all bitter size. So, all right, let's do another one. Guys, this is really offensive. Do you see how this is leaving the streaks on the board? Like, I don't know if that's vinyl oxide in the air. I don't know what it is, but it's really, really, really upsetting me. I'll leave the formula up there. Oh. Oh, gosh. Ugh. Here we go. Okay? For this example that we're going to do, instead of using F and G prime, I'm going to use U and DV, just so you can see it both ways. And then you can decide which way you like better. Our book uses U and DV. So here we go, ready? So what do you think, based off of our rule of thumb? U is F. What's a good choice for U? X. You can differentiate that like all day long, right? So dv is going to be e to the x dx. Okay? Technically speaking, when you use the u and the dv notation, you should be putting dx's on here. If you forget the deal, what's going to get you hit me with one of those chains. No one's gonna do that. Not gonna get tortured. Okay. So we gotta find 4 parts before we use the formula. So what's du? 1 dx. What's v? E to the x. So here we go. The formula says uv minus the integral of v du. Yeah?
So there's man, with my handwriting, my U's and V's is almost exactly the same.
That's why you probably should use that from G.
Right now.
Okay? So now we got to do this integral. What's the antiderivative of e to the x times 1 dx? E to the x. And guess what? We're done. What? No, we're done. Yeah. If you think about it, with integration by parts, every single integration by parts, you have to find at minimum how many antiderivatives? At minimum, you have to find 2 antiderivatives. You have to antidifferentiate twice. Notice I said at minimum, which implies you might have to do it more. When would that happen?
But if we have a situation where we have to use the integration by parts and then while solving integration by parts and integrate by parts.
Yes. Or would you ever have to integrate by parts multiple times within a problem? Yes. Do you ever have, is it ever that you might have to do a use of within integration by parts? Yes. Okay, the ones, the examples that we're starting off with are pretty simple because we're just learning, right? We're going to spend a couple days on this. Let me just show you real quick, Samuel. Like, just see if you can see it. If I would have changed this problem right here to that, what would have happened? This would have been x squared. This would have been 2x. So when I did v du, it wouldn't have been e to the x times 1. It would have been e to the x times 2x. And then guess what do we have to do right there? Integrate by parts. Okay, we'll get there. Let's do this one real quick before we go. Now you're going to look at that and you're going to be like, whoa, hey, I don't see 2 functions there. Do you see 2 functions there? No. But if I'm telling you we have to integrate this by parts, you only have one choice. U has to be, or f of x has to be natural log of x. And g prime has to just be 1. Why is it that way? Because if you flip that, think about this for a minute, kids. If you flip this, you would have to anti-differentiate natural log of x. But that's what we're trying to do. Right? What's f prime? 1 over x. What's g? X. So now do the formula. X, natural log of x, minus x times 1 over x dx. And what does this simplify to right here? 1 dx. And what's the antiderivative of dx? Just x. So there's the antiderivative of natural log. Okay? If you remember when we learned the product rule for derivatives, I gave you that problem to do. I said, take the derivative of that. You got natural log. And I said, hey, you know what? There's a function whose derivative is natural log. Somebody in my period said, hey, what's that one? So here's the deal. There's problems that I put on classroom yesterday for this section on integration by parts. I want you to start working on those. You are going to struggle. It is going to be hard, and it's okay. If you don't get them all, it's fine. Like, we are just now getting into this, okay? See if you can set it up. Set up what you think is F and G prime, or U and DB, if you want to do it that way. And try to see what you can do, yeah.
One thing I'm curious about is at the end of the year, we'll have another exam. Throughout the entire year, what's the problem that takes the most steps that you've ever seen? Like the biggest
And
problem?
here, it'll be in this chapter, this unit. It's either, I mean, you could do an integration by parts problem that if you have to integrate by parts 4 or 5 times, like, that can be kind of messy. A trig substitution also can get kind of messy. You guys have a great weekend. I'll be seeing you. Yeah.
Really? Yeah, I feel like if Haley has to say something, it might be that.
I decided, oh, I want to get the actual answer, and so I adding it into thing, and it was like paragraph long problem.
Yeah, we'll have some integrals that you can easily pick up an entire page.
So, I don't think. I think you better try to number one. Like, is it better?
I don't know, I haven't been.
Oh, on the quiz?